Hello and welcome to all students. Today in this lecture we'll learn about polynomials. This is the last unit of this paper. In this unit we'll learn about polynomials over R. What is meant by polynomials over R? Next we'll learn about the algebraic structure of R of X, polynomials over algebraic structure other than R, divisibility in R of X, greatest common divisor of polynomials, Euclidean algorithm, co-prime polynomials in R of X, some examples. Then we learn about irreducible polynomials, unique factorization theorem, roots of polynomials in R of X, and polynomials in C of X. Okay, so all these topics we have to study in this unit. So in this chapter we learn the domain of polynomial, which not only is an integer domain like Z, it satisfies all the properties of divisibility. It has a prime factors called irreducibles, division algorithm GCD, and so on. A polynomial is an algebraic expression like 3x square plus 5x minus 1, 2x plus 7. Everybody is familiar with it. Right from school days, their addition and multiplication is a common knowledge to all. The polynomials with coefficients from various algebraic structures will be discussed in this chapter. We begin with the polynomials over R. Let capital X be an unknown quantity to be determined with which commutes with real numbers for a positive integer n, and let x raised to the power n is equal to x into x dot 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 n times product. X raised to the power 0 is equal to 1, and the product of x with 1 is x. Then a polynomial over R is a finite expression of the type f of x is equal to a0 plus a1x plus a2x square plus dot 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 plus an into x raised to the power n, where each ai's are called as coefficients, where each I greater or equal 0 less equal n is a real number and an is not equal to 0. Here we note some points. The algebraic constant x is called the indeterminate. ai's are called the coefficients. N is called the degree of n is called the degree, and an the highest degree term of the polynomial is called the leading coefficient. Okay, so an is the coefficient of highest power of x. Therefore, an is called as the leading coefficient of that polynomial. Whenever the leading coefficient an is 1, then that polynomial is called a monic polynomial. Here a naught is called the constant term. It is the coefficient of x raised to 0. If any term x raised to the power I greater or equal 0 strictly less than n does not appear in the expression, it means that the coefficient of x raised to the power I is 0. The 0 polynomial is the one whose all coefficients are 0. The degree of 0 polynomial is not defined. A constant polynomial has only a constant term. For example, f of x is equal to a naught. So a naught is a constant, and this is therefore f of x is a constant polynomial. The degree of a non-zero constant polynomial is always 0. The set of all polynomials over R is denoted by R of x. The set of all polynomials over R means the polynomials with real coefficients. Algebraic structure R of x. So let us we see some algebraic structures, means addition, subtraction, equality, division. So as we write the algebraic structures, addition of numbers, multiplication of numbers, division of numbers. So on the same basis or on the same line, we study here the algebraic structures of R of x, like equality, addition, subtraction, and scalar multiplication. So first of all, we see the equality. Two polynomials f of x is equal to a naught plus a1x plus a2x square plus dot 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 plus an x raised to the power n, and g of x is equal to b naught plus b1x plus b2x square plus dot 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 plus bn x raised to the power m in R of x are called to be equal if and only if m is equal to n, and second is ai is equal to bi for each I is greater or equal 1 less equal m, and m is equal to n. So two polynomials are equal if the coefficients of like powers of x are same and the degree of that polynomial, both the polynomials are same. So this is the simple. Now let us we define the addition of two polynomials. If f of x is equal to a naught plus a1x plus dot 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 plus an x raised to the power n, and g of x is equal to b naught, and g of x is equal to b naught plus b1x plus dot 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 plus bm x raised to the power m are two polynomials in R of x, then f of x plus g of x is given by, so f of x plus g of x means addition of these two polynomials is given by, so how to do addition? See here, a naught plus b naught plus a1 plus b1 x plus dot 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 plus an plus bn x raised to the power n. So this is the addition of polynomials f of x and g of x if n is equal to m. Means what we have to do here? Here we have to add the coefficients of like powers of x. Okay, so constant term add into constant term plus coefficients of x raised to the power 1 add into the coefficient of x raised to the power 1 plus coefficient of x raised to n, add into coefficient of x raised to n into x raised to n. So this is the way to add the two polynomials. Okay, so it follows from the definition of addition that addition is a arbitrary addition is a binary operation in R of x. That is, if f of x and g of x belongs to R of x, then f of x plus g of x also belongs to R of x. Okay, if f of x plus g of x is not equal to 0, then degree of f of x plus g of x is always less than or equal to maximum of degree of f of x and the degree of g of x. That is, if f of x is equal to 3 plus 2x plus 5x square minus 6x cube and g of x is equal to 4 plus x minus 5x square plus 6x cube, then f of x plus g of x is equal to 7 plus 3x and its degree is less than degree of f of x and less than degree of g of x. So addition is associative and commutative in R of x. Okay, because the addition is associative and commutative in R, the 0 with respect to addition is the polynomial, is a 0 polynomial in R of x. And the negative of polynomial, if we have a polynomial f of x is equal to minus a naught plus a1x plus a2x square plus dot 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 plus an x raised to the power n, then its negative minus f of x is given by minus a naught plus minus a1x plus minus a2x square plus dot 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 plus minus an x raised to the power n in R of x. So if we have a polynomial f of x, then how to obtain its negative? Just give a negative sign to each coefficient. Now next we write the multiplication. If f of x is equal to a naught plus a1x plus dot dot plus an x raised to the power n and g of x is equal to b naught plus b1x plus dot 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 plus bm x raised to the power m are two polynomials in R of x, then f of x into g of x multiplication we will see in the next lecture now.